So I recently came across this video on YouTube, and it made me think, why not Blender? Geometry Nodes is not behind. So I decided to create a similar effect, and here's the GeoNodes tutorial for it. The entire process will be divided into 5 parts: importing the base logo mesh, converting it into parallel lines, which will be our threads, animating the threads to appear and tighten on the fabric, adding thickness and creating materials, and creating the border embroidery. Let's get started. To begin, we'll bring in our Nike logo for this demo. Logos are usually available online as SVGs, and we'll be working with that. This Nike SVG is available for free below. Get the link in the description. By default, it's a closed curve. We'll convert it into a mesh. Set the origin to geometry and bring it to the world origin. Scale it up a decent amount so we can work on it. Remove this base material it has come with. We'll create our materials later. When you go to edit mode, you'll see all these edges on the surface. It is recommended to press F and make them all a single face. But for the purpose of this video, I'll keep it as default so you can see the result. Let's add a ground plane, which will be our fabric. Once set, apply all the transforms so that we don't get any issues later. We'll open the geometry node editor below. Let's give it a name. Our first step is to convert the mesh into threads. To understand this part, I got a major help from this person that goes by the username Lord of the Fleas on Blender Artists, and I'll explain how it's done here. We'll first get the bounding area of the logo to get its minimum and maximum points on the XY plane. Now let's get the lowest value and the highest value of this area to get the starting and ending points for a curve. For that, split the vector to get the X, Y, and Z for each. Next, find the minimum value among the X and Y for the starting point, and a similar step to get the maximum value for the endpoint. These will be our X coordinates as the curve passes over the mesh in the X direction. Y remains 0. Add a curve line node and plug these vectors to the start and end point. This is the base curve that goes over the logo. I want to make the curve a little bigger than the logo here, so I increase its length. In our case, the Z value is 0 since the logo is flat on the ground. But in a situation where the logo is tilted, so the start and end values of Z are not 0, we need to find the midpoint of the Z direction to pass the curve through it. Once this curve is set up, we'll now place points on it and spawn instances on it. These instances will be grid planes that cut the logo mesh into slices. The longer side of the grid will be equal to the longest length of the bounding box. For the shirt side of the grid, it's the vertical length, which is once again the differences between the extreme Z values. Add a small amount to this, since in our case the difference is 0. Let's rotate this grid to make it vertical and also scale it by some amount. To instance this grid on our curve, we'll use the Instance on Points node. Since we want more grid lines to intersect, we resample our curve and add points. This will later be our number of threads. Once Instance is finalized, remember to realize them. Next step is to perform the Boolean operation and make intersection cuts on our logo. Once Boolean operation is done, we then need to delete these grid faces so that we're only left with the chopped up logo. For this, we capture the grid meshes as attribute and delete them. Go to Wireframe to see these cuts. The final step in this process is to delete everything else except these parallel edges that were earlier our cuts. This will give us the threads we need. To do this, we'll take this mesh we have currently and delete from it the original mesh we started with. First, let's find the midpoint of each of these edges. Next, we use the proximity node to find the distance between the edges of the original mesh and the midpoints of current edges. If the distance is less than a certain threshold, those edges are deleted. There, we have the start of our threads. Before moving on, I want to rotate these threads by a certain angle. So let's go back to where we made the grids as instances. I'll add the rotation in Z-axis here. Combine X, Y, Z takes in angles as radians, so I'll convert degrees to radians first. We'll make this angle our first user input. Our next process is to animate these threads to have an appear and tighten motion. Let's start by converting these edges to curves. Resample each curve to have only 2 points. We'll also set the curve type to Bezier to give them a smooth bend. Also set the endpoints to have vector handles so that we get the U shape instead of the omega shape when they bend. Now let's bend these curves by using the handle position node. At this point, you must have noticed this issue, where each of those curves is actually a bunch of smaller curves. This is because these edges were cut into smaller pieces by the topology of the original logo mesh during the intersection step. This is why I advised in the start to make the logo mesh as a single face to get better results. Let's do that now and see the difference. We'll now continue with our process. Here the handle position was only set for the left side, so I'll duplicate it for the right side as well. Now we want these offset values to be animated and controlled by a separate body. For that, I'll make a new target object, a cube. Remember to apply transforms. I'll give it an animation to move along the x-axis. Bring in this target mesh into the node editor. Make it relative. Make sure to realize instance. We'll use the proximity node here to get its relative position and also the distance value. Let's plug the distance into the z value. We clearly need to use a map range node to control the value. It's better, but still not the effect I need. I'll use a color ramp to further refine it. That's more like it. The gray value for the third marker controls the bumpiness of the embroidery after it has settled. Next, let's create the appearing animation so that the threads ahead of the target are not visible. For this, we'll use the trim curves node. The end value here is what will be controlled by the target. To do this, we first find the position difference between the target and the curves. As the target passes each thread, this difference goes from negative to positive. We'll plug this in the end socket. Also make sure to clamp the values so that they go from 0 to 1. We're almost done here. Let's turn these into actual threads and do the final material work. Add a curve to mesh and use a curved circle as the profile. We can see here that the thread tips appear before time. To fix this, we'll add in a curve radius node. I'll use the curve length and color ramp to make the tips sharper. One thing I forgot to do here was resample the curve once the animation was done. This adds edge loops to the threads. Our curve radius works correct now. Finally, let's set the material for these and create a material. I'm going to add another user input here, which is the number of threads. Add a noise texture for the roughness. You'll see the roughness not appearing properly. For this, we need to change the vector source to object. Let's reuse this for normals as well. It's pretty obvious that we should add a thread's normal texture to this as well. You can find a few on the internet and use them. Align the angle to the direction of the threads. I'll also use the same texture to add some AO. It looks sorta decent now. One thing I want to add here is some variation to the position of each curve, which improves the realism. We'll add some noise to the original position. The noise only adds in the positive direction and not negative. That's why the threads are moving away. For this, we need to subtract from the noise. That fixes it. The last and quickest process is to add the border embroidery. The steps are similar, but not exactly the same. Let's take the original geometry and delete only the face so we're left with just the edges. We'll convert this into a curve. To add a specific number of points on it, we'll resample it. I'll spawn threads on each of these points by placing instances on points. My instances are curve lines. I give these lines a start and end so that the midpoints are on the logo curve. This value now becomes the length of my lines. We'll add a user input for the thread count here as well. Next, I want these lines to rotate along the direction of the main curve's normal. For that, we first capture the normal information of the curve using capture attribute. Normals are vector properties. Before plugging this in the rotation, add a line Euler to vector node. Using the Z direction gives us the correct rotation we want. They follow the main curve's direction. Once this is achieved, we can now reuse some of the node setup from the main embroidery. I'll duplicate the ones that make the animation happen. You'll notice animation's not working because we didn't realize the instance. Remember to realize instances. I'll modify the color ramp node values to work for the border threads. Let's duplicate the last set of nodes as well. I'll give the border a different color. Finally, join the main and border geometries to get the full effect. Remember to turn off rendering for the target mesh. I'll add a fabric texture to the base as well. I find the curves very uniform, so I'll add the noise variation to the border, just like the main. We need to reduce the multiplier for this one. Height of the border can be adjusted from the color RAM gray value here. And we have our embroidery animation ready. Add a logo of your choice and render out a video to test the animation. This is the main idea behind how this effect can be done. The effect can be improved more from here. I've made a slightly advanced version of this node setup by adding effects like the thread's starting points being from both directions instead of just one side, which adds to the randomness. The threads being thinner when they spawn and gradually getting thick as they settle down. Control of time delay between the main threads and the border thread spawning. Better performance for other kinds of meshes or unique shapes as well. And more user input control in the modifier stack. Download this complete project file on my Patreon from the link below. Hit like if you enjoyed it and subscribe if you wish to see more. I want to specially thank my patrons for supporting me, which allows me to pursue new projects and carry out R&D work so that I can bring out tutorials like this. Hope this was useful and thanks for watching.